Okay, it's an optional problem, and I want you to solve this equation here for the x in the real number system. So it's a fourth degree polynomial, and you're expecting to find four solutions over here. All right, so what I would do, just looking at it, is I would probably simplify it initially. And how would you do that? I guess I would square the 1 minus 5x squared, which is relatively simple. It's going to be 1 minus 10x squared plus 25x4, and that equals 1 minus x. And I'd multiply the 5 across now, so it's going to be 5 minus 50x squared plus 125x4 equals 1 minus x. I'd probably solve for 0 and put it in proper order too. 125x4. Let's see, minus 50x squared. Let's see, plus x, and then take 1 from 5, you get 4. All right, let me show you where this is written, and this is written over here. So, I'm seeing equals 0. I'm seeing the 125x4. I'm seeing minus 50x squared. I'm seeing plus x, and I'm seeing plus 4. Now, certainly, looking at it, what I would do is I would use a rational root theorem, but unfortunately, it's not going to work. So the roots, the potential rational roots would be, let's see, the factors of 4 would be 1, 2, and 4. And for 125, you'd get 1, 5, 25, and 125, and nothing's going to work, all right? So there's no rational roots, no rational roots, all right? So if there's no rational roots, what you're going to do is you're going to try to factor it, all right? Now, certainly if there's no rational roots, my assumption is going to be it's going to factor into two, what's called quadratics that don't have rational roots, of course. So what I do is I made a stab at it, and I'm using what's called trial and error. Now, although it's not the best technique, it does work. All right, so I write this one down over here. And someone says, how did you know that? I didn't know that. So I tried something. So for example, I look at this thing, and I would say factors there. That's 5 cubed, right? So it could be 5 and 25, and it could be 1 and 125. There's not much choice in that. Now the 4, there's also not much choice in the 4. Well, the 4 could be, 2 times 2, 1 times 4. You get the idea. So I tried this, and what I mean by that, I'm trying to get the first and the last guy. And I realized I got some internal terms over here. And my issue was, I knew there was going to be some signs here. And I make a stab at it. Let me get my eraser out, and let me point out what the stab is I made. And this is not the best thing in the world to be doing, by the way. By the way, there is a quartic formula, but it's bizarre, and we're not going to go there. If you want to go to Wikipedia and look it up, you can, though. All right, so, looking at it, you just multiply it out. And what would you get? Well, it's really not bad. You get 125, x to the 4th power. And then at the very end, I would get the plus 4. It's the internal guys that are causing so much trouble. And I'm going to look at that. And the next thing would be cubics, right? So let's write the cubic term down. So plus, there's going to be a cubic term over here. And where would that come from? Well, it come from, let's see, 25b. I get a cubic term from that. And the other cubic term would come from 5a. Now, what do I notice about that? 25b plus 5a must be equal to 0, because there is no cubic term. So 25b would equal minus 5a. So I'm going to say a would equal minus 5b. All right, let me show you where that's written down. That's written over here. All right, so I'm pretty comfortable with that. Let me go to the square term, though. All right, so I'm going to erase this over here. I'm done with that. And I want to put the square term down, because there is a square term there. And what would the square term be? Let's take a look at it. The square term would come from, and again, we got the cubic done. I'm going to the square term now. Let's write the square term down. What is it? Would it be? It would be, let's see, plus, well, you definitely get minus 25. And what else would you get for a square term? You get AB, and you would get minus 20. Now, what do I know about that? I know that's minus 45 plus AB would have to equal minus 50. What does that mean? AB is now minus 5. all right? So that's important to know that. And I got this over here too, all right? Let me go for the linear term, and that's, 1x. Let's write that down, 1x. I'm doing the x now, the linear term. And what would I get over there? I guess I would get minus a. I'm just looking at the product, by the way. And you would get, let's see, plus 4b. So I got a lot of information over here. And, the information I'm getting, ab is minus 5. I'm expecting these to be integers, by the way. And 1 equals minus a plus 4b. And I'm getting a equals minus 5b. All right? So I think I'm going to use this equation here and this one over here. So write this down. So it's going to be 1 equals, well, a is going to be minus 5b, so it's going to be, let's take a look at that. Did I write that right? Minus a, oh, I'm sorry, minus 4b, my mistake. Because I'm not getting an integer if I had that. I'm going to erase this over here, and that's minus 4b. Sorry about that. Whoops. All right. And I'll erase this up here too. Again, I immediately noticed I wasn't getting an integer, and I was saying that can't be. So what do we got over here? We got the a is minus 5b, so this would be 5b minus 4b. So now 1 is equal to, oh, b, look at that. So b is equal to 1. Now if b is equal to 1, I think I know what the a is. The a would be minus 5. So now I got it factored. All right, now certainly if you're a doubting Thomas, you can multiply this out if you want. And if you multiply this out, you get this over here. Now someone says, what are you going to do with that? It's a lot easier for me now. It's quadratic. All right, now I have a formula that's a really easy formula to come up with, and it's also an easier formula to use, unlike the quintic one and the fourth degree one. The quadratic's quite easy. So let's make sure I write that down right. So let's see, did I say that? Minus 5. Yeah, I got it. This is good. So let's write down the solutions to these problems over here. And there's going to be 4 of them now. And you're going to get x equals. We're doing this one now. Let's see, that's going to be 50 on the bottom. 5 plus or minus, well, it's going to be a tough one. Let's see, 25 minus 4 times 25 times a minus 4, that's going to be 400. I got to simplify that. That's 5 plus or minus. And I'm going to say there's a lot of 25s there. There's going to be, let's see, 17 of them. That's over 50. And I want to reduce that. And what do you get there? Or simplified, I should say. 5 plus or minus 5 root 17 over 50. I'm going to reduce that now by dividing top and bottom by 5. You get 1 plus or minus the root of 17 over 10. Let me show you where that's written down. That's written right over here. Let's do the other one. And I'm going to do this one now. All right, that's going to be a little bit easier for me. What do you get over here? X equals, let's see, 10. Let's see, minus 1 plus or minus. And I got to do this now. So 1 minus, let's see, 20. That'd be plus 20 then, right? What do you get there? X equals minus 1 plus or minus the root of 21 over 10. Now, most people leave it that way. I kind of get disturbed by looking at that. I factor a minus 1 out. So it would be 1 minus plus root 21 over 10. And let me show you where that's written. This here is written over here. Now, certainly that's not a bad way of going about it. The problem for me, though, I'll be honest with you, is equating coefficients, which is something we really didn't discuss in class too much, but it's not a bad technique. It's a technique a lot of other teachers would spend more time on. But again, we have limited amount of time to spend time on this, and we really don't equate coefficients. Most of our problems are simple linear problems where division lends itself nicely to figuring out those coefficients. So what I want to do is a different method. And what I noticed about this over here, looking at the original equation, And the original equation is, let's see what it is this thing over here. And what I did was I kind of rewrote it. One thing you do is add x to both sides. Another thing you could do is you could subtract, 5 times the quantity 1 minus 5x squared from both sides. And then what I said I want to make it simpler. And this is something we do in mathematics a lot. We try to make something simpler to look at. So I'm looking at this over here, and this is x equals 1 minus 5, 1 minus 5x squared. So what I did was I said let u equal to 1 minus 5x squared. All right, that's not a bad thing to put down. And if I did that, the point of that is to plug it in here. All right, and if I did that, what would I get? I would get x equals 1 minus 5u squared. Now I'm going to work with these two equations now. And what I want to do with these two equations is, I know it's certainly interesting to have the letter to it, but I'm going to subtract them. All right, and if I do that, what would I get? I would get u minus x. Well, the ones would disappear, and you'd be minus 5x squared minus a minus 5u would be plus 5u squared. And I'm going to rewrite this as, let's see, 5x squared minus 5u squared, and then I write down minus x plus u, get in the same order, by the way, equals 0. And I'll factor this. The first two, factor by grouping, it would be 5, and you would get x squared minus u squared, which would be x plus u, x minus u. And I'm going to factor a 1 out from this, and that's going to be 1 times x minus u. That equals 0. I'm going to factor out x minus u now from those two terms. And what he left off with? Well, 5x plus 5u minus 1 equals 0. Well, what do I know about this? I know x equals u. That's one solution to the problem. The other solution to the problem is going to be where 5u is equal to 1 minus 5x, or u would equal 1 minus 5x over 5. Let me show you where this is written. So we're looking for this. I see that there. And we're looking for this over here, and I see that right over here. All right? Someone says, what are you going to do with that now? Well, I'm not interested in really you. I'm interested in what x is. So I'm going to plug it in somewhere. And so what are you going to plug it in? We're going to plug it in. Well, I guess we could plug it in here. Oops, sorry about that. We're going to plug it in here. All right? So let's take a look. We want x, right? So I'm going to write this over here. So what would x be? I'd get x equals, whoops, sorry about that. I would get x equals 1 minus 5, and if x is u, right, I'm using this over here, I get 5x squared. Now, remarkably, this equation here, if I solve it, it would be 5x squared plus x minus 1 equals 0. Let me relate this back to something that we just did. And we see that right over here, 5x squared plus x minus 1 equals 0, using a zero product rule. Now, let's do this one over here now. And we're going to get the same thing, by the way. Now, what do I write down? Let's write down. You're going to get x. Let's see. U is equal to 1. Again, let's use this one. All right, so what do you get over there? You would get 1 minus 5x squared over 5 is equal to 1 minus 5x squared. Let me see if I did that right. U is equal to 1 minus 5x. Oh, I'm sorry, I made a mistake. I was wondering, that doesn't look right to me. That's why I was saying it doesn't look right. So u is equal to 1 minus 5x over 5. Yeah, let's simplify it. What do you get over there? You would get 1 minus 5x equals 5 minus 25x squared. Well, that's going to be 25x squared minus 5x. Take away 5 from both sides, minus 4 equals 0. And again, I want to point out that this thing also, we've seen this guy before. We've seen him. We've seen this guy before. We've seen him 25x squared minus 5x minus 4, right over here. And they're both. And we solved those already. And we know what the roots of those problems are. They're right over here. So we can get the same exact roots. Now, granted, I realize lots of people looking and saying, which is the best way to go about that problem? I don't think there's any one best way to go about any problem over here. But you showed two alternatives. One was making a substitution. One was just trying to factor the problem. I do tend to like trial and error, by the way. By the way, trial and error always doesn't always work. But the bottom line is, if you're asked to find the real roots of a problem, I'm pretty sure if you find the real roots of something, a fourth degree polynomial, that trial and error is going to work for you pretty nicely. Again, thank you for paying attention.